All right, Frank. So here's our function. We need a fourth degree polynomial. It's Maclaurin, so our center 0, right? Let me just move my camera a little bit. Okay, so we know what we need, and you got the answer right, so apparently you got it. But let's look at these derivatives. They're really not as bad as you think. So f of x is the original. F prime of x. So this is how I take the derivative. Derivative of the top times the bottom minus the top times derivative of the bottom all over bottom squared. And that one wasn't so bad, right? But probably as we move on, it will be. If I clean this up, I'm going to have 5x plus 5 minus 5x plus, plus 3 over bottom squared. And the 5x's are going to cancel, so it looks like we've got 8 over x plus 1 squared. Now it's going to get easy, because the numerator is just a constant. So I'm going to rewrite this as 8 times x plus 1 to the minus 2, and I'll use chain rule to derive the rest. So the second derivative is going to be negative 16 times x plus 1 to the negative 3. Derivative of the inside is 1, so I can bypass that. F triple prime of x is equal to positive 48 x plus 1 to the negative 4, and times derivative of the inside again is going to be 1. And then finally the fourth derivative is going to be, what's 48 times 4? 192 it looks like. So negative 192 x plus 1 to the negative 5. Okay, and since I have to evaluate these things at 0, I'm going to rewrite them. I always do. So let me just come down here and just say, you know, that f of x, I'm sorry if you hear my phone going off, but those are colleagues. So f prime of x, we're going to write as 8 over x plus 1 squared. F double prime of x, we're going to write as negative 16 over x plus 1 cubed. The triple prime is going to be 48 over x plus 1 to the 4th. And finally, that fourth derivative is going to be negative 192 over bottom to the 5th. Oops. So a little nicer, right? If we can get, I couldn't do it here. Oops. I couldn't do it up here because, you know, I had to take the derivative using the quotient rule. But I mean, I could have used a product rule and brought this up to the negative 1, but product rule irritates me. I'd rather use the quotient rule than the product rule. So anyway, just so you know. Okay, so now if we evaluate each of these at 0, this should be nice and easy. F of 0 is going to be negative 3, and f prime of 0 is going to be 8. F double prime of 0 is going to be negative 16. The triple prime at 0 will be 48. And the fourth derivative at 0 is going to be negative 192. So now we can go ahead and plug this into our polynomial. So p sub 4 of x is going to be negative 3 plus 8x minus 16x squared over 2 factorial. So I'll clean that up in a minute. Plus 48x cubed over 3 factorial minus 192 x to the 4th over 4 factorial. And that looks like it's going to be negative 3 plus 8x minus 8x squared. 6 goes into 48. 8 times 6 is 48, right? Let me use my calculator. Yeah, okay. Plus 8x cubed, And then 4 factorial is 24, so 192 divided by 24, yeah, it goes in minus 8x to the 4th. And that's how you would enter your answer into ESB. And again, you had the right answer, so I believe you did it right. You just may have gone the long way and done maybe quotient rule with these tedious remaining derivatives, which would have been a big pain. So just keep that little trick in mind, that you can bring those bottoms up as a quantity to the negative exponent, and that should make it a little bit easier for you. Hope this helped.